Have you ever truly watched a simple cup of coffee as it cools on your kitchen table? It's a quiet, everyday event, one we barely notice. But within that small ceramic vessel, a grand cosmic drama is unfolding. The universe is whispering its most fundamental secrets. Why does the heat seem to vanish into the air? Why doesn't the cool air spontaneously gather its warmth and heat your coffee back up? These questions are gateways to understanding the engine that drives the cosmos. The principles governing that cooling cup are the same ones that orchestrate the birth of stars, the death of stars, the formation of galaxies, the intricate dance of life itself. This is the story of thermodynamics. In our journey today, we will explore this profound science. To begin our story, we must first understand its main character, energy. What is it really? We use the word all the time, having energy, saving energy, using energy. But in physics, energy has a very specific and beautiful meaning. It is the universe's capacity to cause change, to do work. It is the fundamental currency for all transactions in the cosmos. Think of it like this. If you want to move something, change its temperature, or alter its chemical state, you must spend some energy. Energy comes in a dazzling variety of forms. Kinetic energy, energy of motion. A planet orbiting its star, a child running across a field. Potential energy, stored energy. Chemical energy locked in a log spark releasing heat and light. Gravitational potential, a rock teetering on a cliff. Rock falling. Conversion to kinetic energy. All these forms can transform into one another. One of the most relatable forms of energy is heat. Heat is not a substance, not an invisible fluid as scientists once thought. Heat is energy in transit. It is the flow of energy from a hotter object to a colder one, driven by a temperature difference. When you touch a hot stove, you're not feeling hotness itself. You're feeling a massive transfer of energy from vibrating stove atoms to the atoms in your hand. This flow is what we perceive as heat. It's a dynamic river, always flowing from high temperature to low. Understanding this distinction is crucial. Temperature measures average kinetic energy of atoms or molecules, a snapshot of how vigorously particles jiggle. Hot tea, molecules agitated. Cold lemonade, molecules sluggish. Heat is the energy that moves because of that difference. It's the process, not the property. This relationship between temperature and heat is the foundation of thermodynamics.